So in this video, we're going to look at everything you need to know about nth term for your GCSE Maths exam. We're going to start off by looking at, well, how do you generate a sequence from an nth term? We're then going to look at, well, how do you get the nth term from a pattern? How do you get the nth term from a linear sequence? And finally, how do you get the nth term from a quadratic sequence? So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and I've got the example on the right, which is you do. So here we're being asked to use the nth term to write the first three terms of the sequence. So it wants the first three terms. So essentially it wants when n is 1, n is 2, and n is 3. So to get the first term, we are going to do 2 times n. So that's just going to be 2 times 1, which is 2. Now to get the second term, we are going to do 2 times 2, which is 4. And to get the final term, we are going to do 2 times 3, which is 6. So the answer is going to become 2, 4, and 6. I'll just make that a bit smaller. So hopefully you've pressed pause and had a go at the example on the right. It wants the first three terms. So when n is 1, 2, and 3. So you can do 3 times n, which is going to be 1 there. And then we can do 3 times 2. And I'm just substituting that into that n there, which is 6. And then 3 times 3, which is 9. So the answer is 3, 6, and 9. So moving on. So again, the exact same rule applies here. We are looking for the first three terms. So that's n is 1, n is 2, and n is 3. We're just going to substitute n into there. So that's going to become 4 times 1 minus 2. And 4 times 1 is 4 minus 2 is 2. And then 4 times 2 minus 2, which is 8 minus 2, which is 6. And then 4 times 3, which is 12. Minus 2, which is 10. So the answer is 2, 6, and 10. Again, hopefully press pause and had a go at this one here. So again, we want the first three terms. We substitute that in using brackets here. So that's just going to become 0. That is 10 minus 5, which is 5. And that is 15 minus 5, which is 10. So my answer here is 0, 5, and 10. So moving on, again, first three terms here. Now we have two n variables within this. So what I'm going to do is use my brackets. We're going to do 1 first. So I'll just make a note of that here. We're going to find n is 1, then n is 2. Since the question's asked for the first three, that is going to be 1. So 1 squared minus 1, that becomes 0. Then we have 2 squared minus 2, which is 4 minus 2, which is 2. And then we have 3 squared, which is 9, minus 3, which is 6. So the answer here is 0, 2, and 6. Now, looking at the one on the right, again, hopefully press pause and had a go. Exact same thing here applies. That take away 2 times 1. So that is 1 minus 2, which is minus 1. And then for 2, 2 squared minus 2 times 2, which is 0. And then 3 squared minus 2 times 3. So that's 9 minus 6, which gives us 3. And the answer becomes minus 1, 0, and 3. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, moving on, we are now given a sequence and we've been asked to find the next term. So we need to figure out what's actually happening in the sequence. So to go from here to here, I can see we're adding 3, and then we're adding 3 again, and then we're adding 3 again. So which means that to get this next number, the fourth number in the sequence, we just had 3. So the answer here is 13. Again, hopefully press pause and add a go on the right. And hopefully you notice that each one of these is going up by 4. So if I add 4 here, that means the next term is 26. Now with this one, again, the exact same thing. Look at the difference. So from here to here, it's plus 3. From here to here, it's plus 4. So then from here to here, we can say it must be plus 5, which then gives us 25. Okay, so again, hopefully you've pressed pause and had a go at this one. So from here to here, we are subtracting 20. So from here to, we are subtracting 10. From here to here, we are subtracting 20. So we can then say, well, from here to here, we're going to subtract 30, which gives us 40 here. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Moving on. So we've been given the first 4 terms of a linear sequence and been asked to find the nth term. So now to find the nth term, step 1, find the difference between each step in the sequence. So that's plus 5, and then we can write 5n, so you can see where the 5's come from. And then to get the final term, we just need to go backwards. So if we're adding 5 to go to the right, this term here must be 10. So we can just say plus 10. So that is how you find the nth term. And now, if you want to see if your answer is right, you can substitute. You've been told you've been given the first 4 terms. So this must be term number 1. This must be 2. This must be 3. This must be 4. Now you can substitute any of these back into n to see if the answer is right. So if I substitute 4 into here, so yeah, 5 times 4 plus 10, and I can see that gives me 30. So I can see that the answer should have been 30, and it is 30, which means that this is right. So again, step 1, look at the difference. So each time we're adding 10, which means we're going to write 10n, and then we're going to find the term where it would have started. So going back from the start, that would give us 20. So that would be plus 20 there. So here's some practice questions. You have a go at, press pause, and have a go. Here are the answers. Mark your work. Now looking at this, the only difference now is we've been given a pattern. So in the first pattern, I can see we have 3. In the second one, we have 5. And in the last one, we have 7. And I can see that the difference between each one is a plus 2, which means I can then write down here 2n. And then the final bit of this, we're just going to have to go backwards. So what do we add to 2 to get there? We must have added 1. So this would be plus 1. So again, on the right, so for the pattern, we have 4, 5 here. We have 8 here, and we have 8, 9, 10, 11 here. Add 3 each time. So that gives us the 3n. And then to go backwards, we must have had 2 here. So that gives us the plus 2. So now looking at quadratic sequences, step 1 is the same, find the difference. So the difference between this and this is plus 3. The difference between this and this is plus 7. And then the difference between this and this is plus 11. And then what you do is you find the difference between the difference. So this is going up by 4, and this is going up by 4. Okay, so that's the first step. Find the difference, and then find the difference of the difference. So now that that's done, now what you need to bear in mind is that a quadratic sequence can be written as an squared plus bn plus c. So now we want to write the 3 terms for this. So when n is 1, we end up with a plus b plus c. Okay, so all I've done is I've substituted n is 1 into here, and then here. And then if you look at n is equal to 2, in fact, I'm just going to zoom in a little bit so I have a bit more space to work with. So when n is 2, we have 2 squared, which is 4a plus 2b plus c. And then finally, when n is 3, we have 9a plus 3b plus c. Okay, I'm just going to move that over to the left a little bit. Now we're going to find the difference between these. So the difference between that and that is going to be 3a plus b. And the difference between that and that is going to be 5a plus b. And now we're going to find the difference of the difference, which is 2a. Now, this might have seemed a little bit confusing, but so just to recap that, step 1, find the difference. Step 2, find the difference of the difference. Step 3 is we're going to write the general form of a quadratic sequence, which is like this. And now I'm going to use my colors here because it'll make it a lot easier. We are going to solve for a by using this. We're going to use the difference of the difference to find a. So 2a is equal to 4. A is equal to 2. So we've solved a. Now we're going to use this bit. Oh, let me just make sure I'm using the highlighter. We are now going to use the initial difference, which is that one there, and that, to find b. So we can now write that, well, 3a plus b is equal to 3. So hopefully you can see where that's come from. That's that and that there. And I know what a is because I've already solved that. So I can substitute that into a. So that gives me 6 plus b is equal to 3. So I know that b must be minus 3. So I've already got a and I've already got b. And then finally, we can solve for c using this and this. So if I just zoom in a little bit, we have a plus b plus c is equal to 0. We know that a is 2. We've just solved b, which was minus 3. And then we have c is equal to 0. So we know that minus 1 plus c is equal to 0. So c must equal to 1. So we now, if I zoom out, we now have a, b, and c. If I use a different color highlighter, we now know c is there, a is there, and b is there. We can now substitute that into this formula here. So that means our final answer is going to be a, which is 2n squared, plus b, which is minus 3, so it's right, minus 3n. And then we have c, which is 1 plus 1. So the final answer here is going to be 2n squared minus 3n plus 1. Now, hopefully you've pressed pause and had a go at the example on the right. The first step's exactly the same. Find the difference. Plus 5 plus 6. And then find the difference of the difference, which is just plus 1. And in fact, we can do the last one as well, which is just going to be plus 7. And then that's going to be plus 1. Then we're going to write the general form. So I'm just going to copy this from here so we don't have to write it again. But in the exam, make sure you do write this out. I'll just paste this here. You now have the general form. I'll use my highlighter to do the colors. So we're going to do the difference of the difference first. So we know that I'll do it from up here this time. 2a is equal to 1, which means that a is equal to half. So that's a done. We are then going to look at the wrong color. Need a highlighter. We are then going to look at that. So for b, we are now going to do 3a plus b is equal to 5. So that's me comparing this with this. We know what a is, so we can just do, well, 3 times a half plus b is equal to 5. So we know that's going to be 3.5 plus b is equal to 5. So we know that b is going to be 1.5. So we now know what b is. And finally, we are going to do this. So that is going to be that and that there. So we know that a, I'll use a different color. Actually, I'll use red. So we have a plus b plus c is equal to 5. We know what a is, a half. We know what b is, 1.5. We know plus c is equal to 5. So we know a half plus that gives us 2 plus 3 is equal to 5, which means c is equal to 3. And now I just need to substitute that into here. So that then becomes, so we have a half n squared plus 1.5 n plus 3. So that is the final answer for that one there. Here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And do head over to my website if you would like to download a full worksheet on this topic with the answers. And if you would like to book one-to-one tutoring, I'll leave a link in the description below. And do check out the rest of our content on my YouTube channel. And as always, I'll catch you in the next one.